My name is Cole Kidd, and today my presentation is over predicting airline satisfaction. During the course of this presentation, I will be developing a predictive model to help predict customer satisfaction of airlines. So before we get into any of that, first I just want to talk about the airline industry currently in America. So as you guys know, airlines and airplanes are one of the most popular forms of travel. They're only behind cars, which makes sense because people travel in cars every day to commute to work. But yeah, they are the second most popular travel method. And every day in the U.S. alone, there's an average of 2.6 million people flying somewhere. So that is that's just an average. That's not even like the peak days, like holidays and stuff. So there is a giant amount of customers in this industry. In 2023, the U.S. airline industry made $236.3 billion in revenue, and that revenue is projected to increase each year. But one thing that happened was the pandemic, and a lot of airlines are still recovering from the pandemic. Many people didn't really leave their houses. They were rightfully so scared of the virus, and so that means that less and less people were traveling. In fact, the number of passengers was reduced by over 60% during the pandemic, which is a huge loss for airlines. It's a lot of their customer base, over half. And along with the fewer passengers, they also lost a lot of workers. And because of that, they weren't able to like board as many planes and get as many planes going. And then that all led to a huge drop in revenue that a lot of airlines, while today like it's getting back to the pre-pandemic levels, a lot of airlines are still like recovering. And because of the pandemic, it's raised a lot of people's expectations on service and cleanliness. Now, since COVID is it's not as prevalent, but it's still out there, people are still worried about getting sick or catching a different sickness, and so people are have higher expectations about airlines and like airplanes being clean and having better service because they don't want to risk anything. And that's why now more than ever it is important to retain customers while many airlines are still recovering from the pandemic. So, since airlines are wanting to keep more people so that they can regain the revenue that they lost due to the pandemic, so customer retention is very important right now. And on top of this, U.S. passengers have 14 major airlines to choose from. So if they're dissatisfied with one airline, they can just switch to another one easily. And so the margin for error is very low because people have so many options that they could just switch whenever they want to. And because of this, a lot of airlines have been using customer surveys to kind of like get a glimpse into passengers' like happiness during the flights and what they're looking for. And I think that plugging this survey data in the predictive model can reveal what factors affect customer satisfaction the most, whether it be cleanliness or in-flight entertainment or how long the flight is. It could also predict if a passenger will be satisfied with their flight based on some of these different factors. I think this can help airlines improve customer satisfaction rate, thus increasing customer retention rate, and thus increasing revenue, which a lot of airlines need right now coming from the pandemic. So the data I used, it came from Kaggle.com. I downloaded it. It contains 103,903 unique airline passenger surveys, all structured in an Excel sheet. This includes 25 different variables, including age, seat comfort, in-flight entertainment, and many other variables that might apply to customer satisfaction. This data contains a mixture of nominal and numerical data. Some of this numerical data includes like flight times, delay times, and some other stuff like that. And there are plenty of nominal variables in there too. And this data was primary, and it was also structured in an Excel sheet, as mentioned earlier. And the demographics of these surveys, between age and gender, they had a big range. In gender, it was like mostly 50-50 split of males and females. There's a little more females than males that took the survey, but not a significant amount more. And then the age range of people that took the survey, they range from really young ages, like children, like ages of 10, to like elderly, like age 70, 80. But most of the people that took the survey were kind of in like their mid 30s to 50s. which is the spike in the distribution right here. And another thing that's important to know is that a lot of the people that take these surveys are already loyal passengers to the airline they took a survey for. This right here shows that these are the loyal customers, and these are the people that aren't a loyal customer but took the survey. So a lot of this data is focused on current customers and retaining them, basically. And while I was looking through the data, I noticed two problems. The correlation was fine, but one thing that was missing was 310 variables, specifically in the arrival delay in minutes variable. And so, firstly, to fix that, I added the filter examples operator to the original data set. And this way I could filter out the missing variables from that variable and then put it into a new Excel sheet. And the other problem I saw was that the dependent variable satisfaction, it needs to be changed from a nominal to a binominal variable so that RapidMiner can properly read it and give results on it. And so to do that, I added the nominal to binominal operator. And then I added the write Excel operator to put this onto a new Excel sheet and ran it. And so with the new clean data set without the 310 missing attributes, I decided to put that data set into AutoModel because AutoModel is just a really fast way to compare many different models, and it's really good at optimizing them and really figuring out which one's the best. And so the first step to using AutoModel is to assign the predictor variable role. And so I did this by selecting predict and then clicking on the satisfaction category because that's what we're trying to predict. And then secondly, it wants you to specify within what you're predicting which class of highest interest. And so since we're trying to predict which customers will be satisfied with the airline, I decided to put satisfied as the class of highest interest. It's also important to note that there were a lot more passengers that were either neutral to the flight or dissatisfied with the flight than there were satisfied. And then step 3 is selecting what inputs and what variables I want to use in this data set. And AutoModel has a feature that helps with this a lot. If there's a variable that AutoModel suggests you don't use, there'll be this red dot next to the variable. And so the 3 variables that had this red dot were the attribute 1 variable, ID, and gate location. Attribute 1 and ID are both forms of IDs, and they just are used to identify each specific individual passenger. And so they don't have anything to do with passenger satisfaction, so that's why they got left out. And gate location, I'm assuming that it just wasn't correlated enough to airline satisfaction, because your gate location really has nothing to do with how satisfied a customer is, because it's like a location and it has nothing to do with you getting on the airplane and experiencing the flight. So I ended up removing those 2 variables and then continuing on. And one last thing AutoModel asks you to do is to decide what models you want it to run. And I decided on all of the ones that were offered, including the naive Bayes model, the generalized linear model, the logistic regression model, the fast large margin model, the deep learning model, the decision tree model, random forest model, the gradient boosted tree model, and the support vector machine. And I decided to keep the suggestions for data preparation and column analysis that were over here, the ones that AutoModel suggested. And it's also important to note that some of these weren't already selected. A lot of them said that it might take too long to run, so I shouldn't. But I decided to run them anyways because I didn't want to miss the best model if it took a little bit longer to run than a suboptimal model. So this was the results of the models, and all these stats right here is the classification error, and that's basically saying the percent of the predictions that the model got wrong. So basically, the lower the classification error, the better the model is. And this ranged from the lowest, which was gradient boosted trees, which only had a 4.3% error, to the highest, which was support vector machine, which had a 43% error, which is very big and means that that model was not very accurate. So so far the gradient boosted trees is looking pretty good, and as well, deep learning had a 5% classification error, meaning that it wasn't much worse than the gradient boosted trees. So because of this, I decided to run actually, before we do that, I also wanted to show the times that each model took, and the shortest runtime was the decision tree, which took only 7 seconds, which is very fast and very good, but it also didn't have like the greatest results. And the longest runtime was standard vector machine, which took a whopping 21 minutes, which kind of shows that since that has like the highest classification error and the longest time, that model should just not be included in even my evaluation, because I know that it's definitely not going to be used. And so to compare the models that are more close, to compare them like more closely, I decided to look at the ROC curves. I included the key up here because it's kind of hard to tell right here. But some of the models that performed the best were the gradient boosted tree, which is this green line right here. It shot up really fast, which shows that it was shown to perform the best at predicting true positive variables faster than other models. The deep learning model also kept up with it, even though the gradient boosted trees model did rise a little bit faster than it. It ended up like overtaking gradient boosted trees just for a little bit before evening out. But the models that performed the worst were definitely the standard vector machine and the fast large margin. These are very bad ROC curves, and they don't even get to the point that gradient boosted trees does until the very end. So I decided to leave those two out of my consideration. So with all that being said, and after evaluating each model, I decided that gradient boosted trees seem to be the overall best model in predicting passenger satisfaction. This is because the accuracy was the best, the error was the best. The ROC curve, that and the deep learning model were kind of like neck and neck, but I gave the edge to the gradient boosted trees model. And although it takes a little bit longer to run than the deep learning model, it has the best accuracy results, and it is also a less complicated model than other models that scored close, like the deep learning model. And moving on, I decided to look at the lift chart of the gradient boosted trees model, and this lift chart is very good. 69% of the positive values, which are the satisfied passengers, were captured in the first 3 bins, which shows a strong predictive performance and a high efficiency in prioritizing satisfied customers. And as you can see, the slope on this is very steep. A lot of this is because we have a lot of data, and so that's why it was able to get such good results, but it's also because it's just a good model overall, the gradient boosted trees model. And so these were the results of the gradient boosted tree model. It had a precision of 95.8%. It had a recall and sensitivity of 94.4%, which is basically the amount of true positives it was able to identify correctly. It had a specificity of 96.8%, which is the amount of true negatives it was able to identify, which means like it was able to identify passengers who weren't satisfied, basically, or who were neutral. It had an overall accuracy of 95.7% and an error rate of 4.3%. So looking at the weighted correlations that each variable had to passenger satisfaction, as well as the GPT or the gradient boosted trees model simulator, which you can adjust each variable to show how much it includes to customer satisfaction rate or how much it takes away from it. Airlines can decipher which variables best predict if a customer will be satisfied or not and how to improve on them. Airlines can also advertise these most important factors that they find to attract new customers. So let's say one of the most weighted variables was the in-flight entertainment system. So airlines can improve upon that and then advertise it to like draw in new customers to the airline. And airlines can run this model as well to see whether passengers will be satisfied with their flight based on certain demographics of the passengers and factors of the flight. And so, in conclusion, the gradient boosted trees model developed for predicting airline satisfaction has outperformed other models and has proven to be effective. With a 94.4% success rate and identifying satisfied passengers, it holds significant potential for practical application within the airline industry. And to further improve upon this model, additional predictive variables should be added to further improve the model performance, as well as more recent data should also be added because preferences are probably always changing, and I think a lot of this data was collected before the pandemic. So I think especially now, new data would especially help this model. And that's my presentation. Thank you.